Well, I think Sabrina, are all the groups back in the main room together? Yes?
Yes.
Okay, well then maybe we'll go in breakout room order. So my group, we can go first. Do the participants, are they able to share their screens with the current settings, Sabrina?
Yes, yes, they can.
Okay. So Gianluca in my group, he volunteered. Do you want to share to show people how you've been getting on?
Sure. Just have to check how to. Should I click on share screen? I
Share
guess.
screen.
It's better to share a screen rather than a window.
Okay. I don't know if it's working now. Are you seeing my QGIS?
Yes.
Yes.
Oh, yes.
Okay. So I just read the Mercury tools that was about to assign. Actually, I found that I realized I've created not so many contact features, but this is the map created using the Mappy tool. And I was about to categorize not putting the labels on the, it's not this one, it's geo units. Okay, but this one didn't really come very well. I don't know why. And if I lower the opacity here, so okay, maybe it's a little bit better. So what I've done, I have regarding the contact features, I have outlined the area of the central of the inner ring, and I think I've used as a mapping unit, as a geological unit. I chose the degraded crater material.
Okay.
Okay.
What made you make that decision? What observations were you making?
So I observed. I actually I compared to the surface features which are external to the crater and inside the crater itself. Actually, I think the inner ring is, once it forms, it should appear less degraded than the state that we can look at the current state now. If I, okay, so just looking at the general morphology and the general state of degradation of the inner ring, doesn't look really like a fresh fresh structure.
Okay. What about the rest of the crater? Do you think it agrees? What about the rest? What about the ejecta and the crater rim, for example?
I didn't map them yet. I've seen that some ejecta do cover some other craters, which I mapped as buried craters, such as, I think this one. I haven't mapped them yet, but there are some lineated features which could be probably mapped as ejecta. I'm not really sure, but as far as I've understood, also from the previous lessons, lesson of the moon, this lineated material that spreads from the center of the crater towards the external parts can be interpreted as ejecta.
Yeah.
Okay, so I've seen some ejecta also here at the eastern side of this crater. So as well as in other parts. For example, in this case, I haven't really seen the same lineated feature that I interpreted to be an ejecta. So I mapped this crater as just as a small crater, because to me it looks like a fresher crater, and even this one. I don't know if I'm correct.
Oh, well, I mean, I didn't say in the introductory talk what the size difference between a small crater and a large crater was, so that was a mistake of mine. And there is a measure tool which you can use to measure the scales of these things. And for example, I've made a map of part of this area, and I mapped if a crater was bigger than 20 kilometers, I used the large rim symbol.
Okay, okay.
So if you want to be methodical about it, and I think maps should be made methodically where it's possible, then you can set whatever you want, whatever you like. You should choose the Cartesiano option there.
Yeah, it's 25 kilometers.
Because
large.
Yeah. Okay. So you can use that to help you decide if you want to use the small or the large crater symbol.
Okay. So larger than 20 kilometers is
whatever you want to do, but
okay.
that's what I did. Okay. So that was Gianluca from my group. Valentina, have you got someone in your group who maybe wants to show? Maybe we don't need to do every group because we should spend most time to share.
Okay, thank you. I will be very unpopular because I didn't ask them to volunteer, but I think Matilda can show us something.
Okay.
Let me say that Matilda was very good because she didn't know she had a ready project, and she started from scratch.
Oh, right.
Yeah, but at a certain point we took back your project.
Okay.
Okay. Okay.
Can you see that?
Yes.
Yes.
Right?
Yep.
I restart my map from the big crater, and I tried also here is approximately craters, and here this trust, I think.
So Matilda, how did you interpret this feature as a thrust? What did you look at several base maps? Did you have an evidence to say this is a thrust?
I don't know. I looked for this line and shadows, and I thought that, but I don't know if it's true and if it's correct.
Are there? Can you think of any of the other features that might be in the mapping area that it could be instead of a thrust, say?
Does it look like another feature you see in the area?
Oh, okay.
Just don't go so far. You just can stay in there.
This one?
Okay, so this one you're looking at, this is Calypso rupees. This is a very important rupee on Mercury, and this is actually a thrust. Okay. So you can see to the north a high region, and to the south a lower region, because the sun is hitting the surface from southeast to the northwest.
Okay.
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 And you can see it's quite lobate. So if you go back to your, let's say, thrust feature, if you look at it, you can see some aligned round shapes. You can't really see a higher piece of, okay, stay on this base map. Okay. And turn off your contacts, turn off. Okay, if you look at it, you can see it has very round shapes around it. Yeah. And you don't have an area that seems to be higher and an area that seems to be lower, separated by a scarp. You have actually a sort of trough with round borders. So to me, it looks like a crater chain.
Okay. Okay.
Okay. What, are you convinced or?
Yeah, of course. Thank you.
Okay.
So it's important to use the different base maps because they can help you see if what you're looking at is a crater chain, which is quite a symmetrical feature, whereas a lobate scarp is less symmetrical. And if I were designing this practical again, I would follow my co-leader's advice and give you all the digital elevation model, because then you'd be able to see that a lobate scarp has an elevated side and the less elevated side. So you would be able to tell the difference between Catini and lobate scarps more easily, but we can do that the next time. But I also sometimes with poor illumination struggle to tell the difference between crater chains and lobate scarps. So don't be discouraged. This is a problem that planetary scientists have to cope with all the time. So thank you very much for sharing, Matilda, and thank you for working really hard on your map from scratch as well. It's great to see your enthusiasm. I think
Annie has a question. Jack.
Oh, go ahead, Annie.
Thanks. I actually just wanted to talk a little bit about that large thrust fault. It's just that usually on Earth, you know, these thrust faults are very linear, very straight features. And it almost looks like in the very bottom left-hand corner that they're two kind of, it looks like, if I was interpreting it on Earth, it looks like there are two normal faults that dissect it. I just wondered why it's not as straight a feature as it would be on Earth.
Do you want to share your screen so everyone can see what you're talking about, Annie?
Yeah, of course. Can you see that? I'll take off.
I think something will, yes, it's appeared for me.
Definitely. So I think you see it better. Yeah, there.
Yes.
So that's the thrust fault there.
Yeah.
Now I think if I'd seen this on like just a normal Earth geological map, I would have interpreted this and this as potentially displacement by another fault. Just because you would expect that to be, I don't know, straighter. I'm just wondering why that's so irregular in its trace.
Do you want to take this one, Valentina? You're our structural expert.
Of course, I was trembling here. Okay, you know, Annie, you noticed a very nice feature, of course, characterizing this car. And maybe it means that you're familiar with structural geology. And yes, lobate scarps are usually lobate. As you can see, this thrust, it actually is lobate on the let's say eastern side. But on the western side, certainly something happens. And that's maybe because this thrust is not properly pure thrust. It has no deep slip movement over there. Maybe it has some oblique component that displaces the thrust, and maybe it's not a pure thrust, but an oblique fold intersected maybe by normal folds. We don't know because we do not have, let's say, kinematic markers over there, but it's possible. What we notice on this thrust is, of course, maybe that there are some normal folds on top of it on the central part. To the north of the line that you draw, you can see a little trough. Okay, yeah, there, no? Just on the center of the thrust.
They are very small.
Very
it's quite
small,
tricky to see them.
At the center of the thrust, just south, go a bit south, okay? There.
See, near the little crater.
But there is a little crater just south of the crater.
Oh, I'm really
West.
sorry, I'm not-
Okay, don't worry, don't
It's
worry,
okay.
don't worry.
Up a bit, Annie. Up.
Off of it, okay. keep going.
Left. No, move your hand left. Leave the image where it is.
Oh,
Down.
right, okay.
Come down. Down.
Okay.
Right 1 centimeter.
Yeah, there.
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 Do you see them?
I think so.
They're very, very difficult to see, but zoom in and you might see the little troughs that are riding on the back of the lobate scarp. Do you see?
Yeah, okay.
Yes.
Yes, gotcha.
You don't have to go this zoom, but there is a trough, and maybe over there we have some normal folds. But that's a complicated structure, and you noticed some very peculiar feature that sometimes help us understanding the kinematics of the structures on Mercury.
Papers are beginning to be written about things like impure dip-slip movement on faults like restraining bands and things like that. I'm not a structural geologist, but there are the wrinkle ridges in the smooth plains have very interesting morphologies, and they look like they've got some of this these sorts of kink bands and things in them.
Yeah. Those are keystone grabens that Valentina's just drawn, probably. And Ben is talking about keystone grabens on Mercury at Mexag on Friday, I think.
Mm-hmm.
Thank you, Sabrina, for reminding us to use annotate. Very useful. Right. So that's great. Thanks, Annie, for that. So according to the original program, we would go back into the mapping session now. Shall we have one more share from another group, since I think people are finding this a useful and interesting session, apart from Valentina, who's checking her phone. I see you.
I'm checking with you.
So Dave, did you say you have someone in your group?
Well, yeah, Mark, could you share your screen, please? Because we were each mapping something different. I said to people, have a look around, find something you like. One person's found a thrust which is not Calypso wrup-up, it's a smaller one. Two people looking at cratering features. Mark got interested in Rachmaninoff itself. This is progress. Is this yours being shared now, Mark?
Yes.
Okay,
yes,
I've put the grabens in since. But
my main bit was obviously this bit, the inner ring.
Mm-hmm.
The main bit I was interested in, and trying to figure out what the extent is. And we were discussing it, and what I felt was, particularly from the different light of illumination angles, was that the extent of that inner ring seemed to be quite far out. It was almost like ejecta. That's what it almost looked like, but I'm not sure if it is or if it's just the actual raised area around there. What I'm sort of in the middle at the moment of doing is trying to figure out what these materials are classified as, really. So, and trying to figure out the ages of the different formations. So I'm also looking at the cratering.
Okay.
In particular, obviously this central area, the smooth area with the just really some small craters, not very many at all, larger ones or none. This outer area here, having some slightly larger craters and a bit more cratering. But obviously I'm now looking at the different sort of rings and seeing that the craters and the rings are actually much more degraded. So it makes me think that that's where I'm kind of getting a dating of the rings being by far the oldest part, this outer area being sort of in the middle, and then the central area being the youngest, and perhaps some sort of outflow from that young area into this area down the bottom here, where the ring doesn't seem to be very high. So I'm wondering if it's flooded over. And obviously perhaps some sort of faculi sort of feature here.
Yeah, can you switch on the enhanced color for us to have a look at that?
Yes, there we go. There we are. So I'll switch off the features.
Yeah, okay. So there's definitely a lot of color contrast going on in Rachmaninoff. That's good. Do you have a bit of a geologist's intuition about what's going on here, and you can see the difference in the cratering density. If you're doing the advanced school, you'll be able to do the statistics on that, but you've got an intuition about it just by looking at it, have you?
Yeah, well, I discussed it with Dave as well, obviously, when we were sort of discussing the age with the features. I I was quite interested with the idea of the flow and the idea of this sort of area literally flowing out. And
what was your idea? You didn't get that from me. I think you're right.
Yeah, but also what I've also been trying to do is sort of seeing where this sort of faculae appears to end, or whether it's part of, whether the flow is obviously come after the flow, but whether it's related to something, I'm not entirely sure as well. But that's quite hard to tell whether there's a join, or whether this sort of lighter area continues underneath the faculae and the faculae is on top. I'm not sure.
Is anyone sort of wishing there was better resolution? It's always the problem.
Yeah.
But,
is there a pit that the facula was erupted from, Mark?
I think it looks like there's perhaps something there. Yeah, there you go. So it looks like there's something there. It looks like a pit region, maybe that as well.
It looks to me much shallower than the than other pits that you might find in the area. So it's tricky, this stuff.
But it looks uneven as well, which makes me wonder whether it is, because it's not like a crater.
No, it doesn't look like an impact crater. This I grant you. So an interesting area, very, very interesting. I'm really pleased with everyone's observations they've been making.
It looks like a pitted ground, what we call a pitted ground.
So I haven't made any special provision for that in the project files, but because I didn't want to complicate things overly much. But you can certainly symbolize that as a facula, and we can maybe at the end discuss the complexities of facula and pits as well.
Okay.
But thanks everyone for your observations. I think now we should jump back into the mapping if we can, and go back into our breakout rooms. But thanks everyone for contributing to this little reconvene session in the middle. I hope you found it useful or inspiring.
Hello.
Hello.
Hi.
Well,
Hi.
I don't know about you guys, but I think this has been a big success.
Really?
Oh, you disagree, Valentina?
Oh, yeah, of course it's a success.
I'm very pleased. We weren't ready to stop. There's great stuff been going on.
I know, but I suppose we have to end the session somehow. And obviously everyone is free to carry on in their spare time if they like. Your project files are for you to keep, but if you make any interesting geological observations of Rachmaninoff crater, do let us know, because it's one of my favorites. I think Valentina likes it as well.
Oh yes, I got a structural geologist in my group, and she noticed a very nice features that I didn't notice at start.
Okay, well,
we have a very, very nice feature here.
This is good. This is good. The more eyes who are looking at Mercury, then the more we will discover about it. I mean, I hope that people have taken away from this that they're not merely doing a curious little exercise in coloring in. No, this has been a very important scientific exercise, and hopefully you have been able to determine some relative ages or the relative order of the events that took place in this region. So I'm going to go back to the presentation that I made at the beginning of this practical, and I'm going to see if some people have some answers to the questions that I posed to the group at the beginning. So I'm going to load the presentation, and I will share my screen. Okay. So yes, at the very beginning, I showed you this slide and said there are some questions here that maybe we can have answered. So I've put Rachmaninoff somewhere on the time scale of Mercury, and I've said maybe it formed about 3 billion years ago. What do people think about the explosive volcanism that forms the faculae? Do people think that that was an old event in this quadrangle, older than Rachmaninoff, or do we think it was younger? So I'm going to invite brave people to speak up. Did anyone make any observations that determine this relationship? Go on, we're going to sit in silence if no one speaks up.
I would say younger. I would say very young.
Okay. And what was your observation? What suggests that to you?
Just because it appears to lie over the top of any of the other features.
Okay. So on the slide I'm showing you here, there's one of these large facula there. That's the very bright one in the northeast. So did you observe an interaction between it and Rachmaninoff, Mark?
Oh, that I'm not so sure whether I saw there was much interaction with the Rachmaninoff itself. That's the thing. Because I was looking more inside Rachmaninoff in the actual middle of it.
Okay.
That's where I was really studying. That's
okay. I mean, I gave you all a very big area with a lot going on. So I'm pleased that different people have been interested in different areas. Can someone speak up if they tried to draw the ejector contact for Rachmaninoff the whole way around the crater? Did anyone try that?
I did, but
okay. Barbara?
It didn't color, so never mind.
Oh, well, that's okay. Do you want to share your screen and show us the contact you drew? I can stop.
Really? Okay.
Just the line work is okay. The line work is the most important bit.
Where do I have it now? You see my screen, and do you see now?
I think you're putting QGIS, yes, okay.
Yeah, so it's this line here that it's not showing in color.
Okay, I can see that.
Highlight it if you want. Maybe I can do it this way. There, can you see it a bit?
Yeah, I can see it. So if you put on the, can you put on the enhanced color layer as well for us? Okay, so do people see the way Barbara has drawn her Rachmaninoff ejector contact? Do we think that the facula in the northeast is on top of the ejector or underneath it? What do people think? What do you think, Barbara?
Underneath.
So I heard someone say that it was underneath. Barbara, did you say on top?
Yeah.
Okay, so we've got two opinions. We're going to have to vote on this. We're going to have to have a division. Who thinks that it's on top?
Who offers more?
Do we think on top or underneath? You can vote in the chat if you like, if you're feeling shy.
Pose the question again. I'm not sure which way around you're asking it.
Okay. Is the facula on top of the ejector? Yes or
Which
no?
one?
Oh, is the bright one in the northeast?
Oh,
is that on top of Rachmaninoff's ejector or underneath it? We've got a thumbs up from Ben. I'm assuming that means it's on top. He likes it.
I would say that's on top.
Mm-hmm.
Pretty confident I would say that.
Okay. Yeah.
Otherwise, the ejector would change the shape of the color. It would actually impinge on it.
Yes, but isn't it the ejector that has been tinged by the facula?
Yeah.
So I agree. I think the explosive eruption that formed that facula must have happened sometime after Rachmaninoff was in place. So if we go back to my presentation.
I have a question.
Go, Valentina.
Yeah, because I saw that the facula was drawn very near to the border of the pit.
Yes, the way Barbara drew it. Yes.
Yeah. I just wanted to know how Barbara did interpret the facula, whether she decided to follow the morphology or the color.
So I looked at the colors first to, can you hear me?
Yes.
Am I on? Right.
Yes.
At the colors to first tell where they are. And then I went in the brightest point. I took the map off and I started to play with the east and west light to see where the actual source was, and I mapped it. So it's here, here, and here too, like these.
Okay.
Okay. So you've mapped the very centers of those eruption centers, but if you were to draw again where you think the particles erupted by those events, where would you draw your lines differently?
Well, yes, I would then follow the color, obviously.
Mm-hmm.
The
Okay.
whole, zone and all of this part.
Okay, that's good. So I think we're all in agreement that we think the facula is on top. So they're quite young, we think, compared with the
And
impact.
that's why we use both linear features and surface features. Because of course you see the main center of the explosion, which is the volcanic vent. And for that, you could use the linear features to say, hey, this is the center of the eruption. And then you can use your surface feature to say the eruption went this far to the particles. You can use your features together to tell a story.
So, and then another story we can ask what has happened is, again, focusing outside Rachmaninoff. If I were doing this again, maybe I would have included more to the east of Rachmaninoff as well. But there is some smooth plains in my map here. Over here, do you see the way I've drawn it? So where do we think the smooth plains volcanism is in this story? Is it before Rachmaninoff or is it after? Did anyone look at the smooth plains in the exterior of the crater?
Can you take the color off, please?
Yes, I can take it off.
Well, it must have been there before because the ejector covered the planes around it.
Yes, exactly.
Good, good. I think we all agree. So we can put some things on the presentation and we can begin to build up our story. So here we go. So we think that the facula must have formed sometime after, but we think that the effusive volcanism exterior to the crater must be before. And the exterior volcanism extends over a lot of the planet. Those smooth plains in particular are the youngest examples of effusive volcanism on Mercury. And Dave showed you that in his lecture. And there's enough of it on the planet. It covers a wide enough area that you can do the crater size frequency distribution statistics on it. And that's a technique that some of you will learn in the advanced part of the school. And the statistics on that crater density are reasonably robust. And depending on which scaling rules you apply, you get a different sort of absolute age, but it's something like 3.5 billion years ago. So we've got a good date for the effusive volcanism outside Rachmaninoff. Now, I know Mark was focusing inside the crater. Was anyone else focusing inside the crater? What do we think about the crater interior? Do we think that when the crater formed, it formed as we see it today? Or do we think that there has been some additional activity inside Rachmaninoff? What do people think?
No,
Don't be shy. Oh, Annie, you were speaking, sorry.
Oh, I was just going to say that if we put the enhanced color back on,
yes,
I think you can use the contrast there to justify that the center has a different magma source than the ejecta, which we discussed was that deep blue, because it's kind of the impact itself has been so deep that it's produced a lot of ejecta from source that's quite deep in the crust. And yes, that different color of internal magma implies a different source that is younger.
Okay.
I think there is subsidization happening because there is big gravens over there. So probably the impact was so big that you still have some activity or a hot something behind.
That's an interesting point.
Hot spot or something behind that crater, and it's causing the subsidization of the center and the formation of the ground structures.
Yeah, good. So Rachmaninoff has remained an active site geologically after it formed. So let's go back to our little presentation and put those items there. So we think the effusive volcanism in Rachmaninoff, it must have happened after the crater formed. And as Annie put it, and others have put it as well, I've heard on discussions within the groups, we think that some time passed and then there was a volcanic eruption. And I remember Mark saying in our first reconvene that he thought that there must have been some eruption here that breached the peak ring in the south where it's not so upstanding, and maybe it flowed out as far as these smaller faculae, you know, and that's something that is interesting, and maybe Bepi Colombo will be able to provide even more information. Now, if I had given you all the digital elevation model of this area, you would have realized that Rachmaninoff's actually quite a deep crater, and it's actually in its center is the lowest elevation point on Mercury's surface. And as a consequence, Rachmaninoff has been able to excavate presumably stuff from Mercury's lower crust. And that's in keeping with the idea that this very dark blue material is the graphite-bearing remnants of the early flotation crust on Mercury that basically doesn't exist in an intact form anywhere. But at the very bottom of Mercury's crust, which was then subsequently covered in lavas, large impact craters are able to punch through and excavate some of that from the lower crust. So a very interesting area. And I think that's all I really wanted to say. I just wanted to make sure that people had been able to use their maps to construct a story. It's more difficult to say which do we think is which do we think is most recent of the volcanism inside the crater and out, but the interior of the crater gives us a clue about that. So let's look at it once again. And I think I'll put on the color to help here. So what do people think happened here? There are the faculae in Rachmaninoff and there's the smooth plains. Which do we think is the younger of the two?
Probably the brighter one.
And why do you say that, Evelina?
Well, could you remind me what the yellow color is indicative of?
In this product, it's purely a color product. It's not telling it, the colors don't represent mineral abundances or anything like that.
Okay.
But as Dave said in his lecture, it's almost as if you've just taken a natural color image of Mercury and exaggerated the existing color. So this stuff that appears quite yellowy already is genuinely redder than the stuff that appears blue. But it doesn't say anything about minerals, for example.
Okay, so it's not clear which one will be younger, but I think that when we have all this probably effusive material inside the crater rim, and there are some patches around the crater rim, this may be a sign of another event somewhat later or earlier, like there was a vent opening outside the crater rim. It's not necessarily as if it had flown out, maybe to the southeast, but to the southwest, it looks like another opening to the magma.
Do you think that there were multiple eruption centers in this crater, perhaps?
Well, maybe two. One that filled the crater rim.
Mm-hmm. Oh, the crater peak ring interior.
Yeah, the ring, and
Yeah.
another one to the southwest.
Okay.
Southeast, sorry.
So, well, there's different sorts of. Whoop, not my map. There's a lot of smooth material in the sort of in-between space between the peak ring and the crater rim, and the colors change. So I think, you know, there's a good argument to be made for multiple eruption sites, maybe with slightly different compositions or different ages to explain their different colors. What I found quite interesting about this little facula here, if we turn off my symbols, I mean, here it looks innocent enough on the crater floor, but I'm always struck by the way Rachmaninoff's peak ring material, which is very blue here, cuts into the heart of this facula. And if you imagine an explosive eruption with material sort of raining down, I would expect some of it to appear on this nearby part of the peak ring, but there isn't. And that sort of almost makes it look like the peak ring is younger than the facula. It's sort of fallen on top of it. But what I actually think is happening is earlier on, Valentina mentioned pitted ground, and I just kept my lips shut about what pitted ground is. But we think that pitted ground is a special form of a facula on Mercury, where instead of being formed by an explosive eruption that generates a sort of cascade of material raining down, instead lava flows over ground that has easily volatilized material that readily will turn into a gas, and that disrupts the surface and makes it get this pitted texture. So rather than being an eruption from a vent at its center, I think this is a sort of surface crackling that happens whenever lava flows over material that's full of volatiles. And that sort of makes sense in Rachmaninoff, because we go back to what Dave said about this dark stuff being graphite bearing. It could be that graphite is behaving as that volatile. When exposed to the heat of the lava, it is lost from the surface. And what happens is the facula is red because it has had all of this blue material removed from it. It's a relative change in color. Just an idea. This is all, you know, we're at the cutting edge of science now on Mercury, aren't we, Dave? You know, we need more answers. So these are the sorts of observations you can make with the map. I mean, that's all I wanted to say. I just wanted to put those little items and lists. So if you were to ask me, I would say that the effusive volcanism is older, and the facula explosive volcanism in the area is probably the youngest stuff that has happened, visible at our map scale. Yeah. Valentina, do you have anything you want to add?
Well, I agree with everything you said, and
what a diplomatic answer.
No, I was just thinking that many questions I got during my session were related to the difference between linear features and contacts, and understanding why only the contacts create the polygons, and what do the linear features stand for? Because of course there are also non-geologists here.
Yeah.
Okay? So apart from stratigraphy that Jack explained very well, I'd say that it's important to remember when doing a map that your contacts always have to be closed and linear features can be open. And linear features are useful for highlighting the morphological features that help understanding the story of your map. The geological contacts will define the units that will define the stratigraphy, and then the linear features will locate exactly the geological features that were responsible for that history. So that was just a comment I had, because I had many questions on linear features versus geological contacts.
My trivial point about linear features is they help with navigation. If I just looked at my geological map with none of my linear features on, I'd be like, where am I? What is this weird shape? And then if I put on the lines, oh, of course, it's a crater with some smooth plains inside it. That makes sense.
Yeah. And I think, I don't know, did any one of you map a very old crater?
I mapped ghost
I'm
craters.
buried. Oh, sorry.
Okay.
Go ahead.
Barbara?
Oh, I mapped a few ghost craters. Yeah.
Okay. But ghost craters, did you map them with units?
You mean with colors? Yeah.
Yeah.
Yes. Not all came up, but yeah.
You want to share your screen?
Hold on, I'm trying to bring it back up. Which one is it? This one. Can you see it?
Yeah.
So it would be, I believe, not these ones. Yeah, the green things.
Could you?
Okay. So you assigned a polygon to those varied craters.
Yeah. This one hasn't color.
And,
I don't know why.
Okay. So maybe this, let's say, this regards the issue I was talking before, distinguishing between geological contacts and linear features. So a geological contact defines a geological unit which is on top of everything where we are drawing it. So if something is buried, it doesn't create a geological unit on our map. It is buried. So the only way we can define it is to use a linear feature that will define the shape of your buried crater, but the linear feature won't create a polygon. So in those cases, what you should do is to just...
Well, I had to mark both so that I could see them, because if I used only one, it wouldn't show. So I had to use both, the contact and the linear feature. And then it would color.
Yes, okay, but they don't need to be colored because they are buried. So it means they have another unit. In that case, it's the Rachmaninoff ejecta unit that will bury that craters. So you don't need to color them. You just need a linear feature.
Just to mark them, yeah.
Yeah, you just need to mark them. And then the main unit will be the ejecta Rachmaninoff crater.
I see.
Yeah.
It's I didn't want to spend too much time talking at the start of the practical because I wanted people to get started, and I probably, well, I know that I did not explain everything particularly clearly, but and that's why I wanted us to have this session at the end so that we could set some things straight. So thank you, Valentina.
Thank you.
Can I share
yes,
my screen for a second? Because in the last days, I remember that I tried to work on Rachmaninoff.
Sorry, Paolo, you've turned away from your microphone. Can you
hear me now?
Yep.
I was saying that in the last days, I remember that 10 years ago, and
yes,
why my hair are getting white, because I
please.
worked on Rachmaninoff to map the area. And on the right of the screen I'm sharing, you see the data I used 10 years ago.
Yes.
Those were from the messenger flyby.
Yeah.
And on the left, the image we have available now.
Changed a lot.
all this just to say that 10 years are a lot, of course, but all you mappers that hopefully will work on planetary surface, remember that one mission can really change the way we look at the planet. This has been the case for Messenger. Hopefully, I truly believe it will be the case for Baby Colombo.
Absolutely.
And that's it. You always will have hopefully new data to confirm or or discredit interpretations. And I'm not going to show the map I did with the data 10 years ago because it's something awful, but this is great. And just comparing these two images brings a lot of memories to me and also a lot of fun. Okay, just to say this.
And did you get to participate in the practical in the end, Paolo? Did you find a home?
Yes,
people in it.
I finished in the group of Ben and, helped him with the GIS issues mostly. It's okay.
Okay. Great. Well, we're at past, which is when the practical is scheduled to end. Does anyone have any? Do any of the instructors have any points that were important for their discussions in their groups? I'm happy if the answer is no or not. Yeah.
So when you ask if someone map an old crater, I map a couple old craters like this one in here.
Okay.
It's the form. I think the deformation is associated to these structures here.
Okay, can you turn off your polygon so we can see the base map again, please? Thanks, Pam.
Yeah.
Okay. And are the structures clearer in the monochrome?
Yes.
I warn you, Jack, they are not so clear, the structures, but there are some.
Okay. Why don't you zoom right in, Pamela, and we can see if we can find one of them. Okay. So they're very subtle.
There is some evidence in here, like craters are cut.
Okay.
This old crater is the form. There is alienation, some lineations as well, like association of crater alienation that can be caused by the structures as well. And there is some perpendicular structures of grabens that they're common associated to thrust faults, the perpendicular opening structures.
Mm-hmm. Do you think? Well, now you've shown me.
I think
young crater.
When you were talking about the big crater and the eruptions, and you were asking which event was older or younger.
Yeah.
I think all these thrust faults are actually older than the big crater.
Okay. So do you think they're nothing to do with the impact then?
I think they're older. I was looking evidence if they're associated to the impact, but I don't think so, because in here you see other structures that they have. You see these ones in here. I think these ones are younger, and these ones are associated to the impact. These ones in here, but not these thrust faults. This looks older. Younger than this crater, because this is the older crater I found in the image. This one, one in here, but older than these and these and these.
I think we need a DTM here.
Yeah.
Do you think we've got a DTM, Valentina, with the sufficient spatial resolution? We've got 222 meters for
I
Hokusai.
don't know if we have do you have DLR DTM here?
Yes. Yeah.
Maybe that one would help us. But of all the structures that Pamela wrote, maybe there is one real one, one actual structure, which is very important, which is the one to the very to the west, which is something like a flower structure. It's very subtle, but it's quite discernible for a structural geologist. While the other structures to the east, I think they are risky. I mean, because they are very similar to the lineations that usually crater leaves on the ground, because this was a very energetic impact. So it's very easy to find lineations that remind us of fault structures. So those has to be checked carefully.
Yeah.
While for the old crater that you say it is a deformed crater, I would pay attention because I never saw such a deformed crater.
Oh, I saw them in Pluto, but of course it's a different thing, right?
In Pluto, maybe it's possible, but on Mercury.
Let me show you.
And in here, to say it was a crater, we would need a DTM, but I'm not sure, but I don't know.
This one here.
It looks like a structure itself, yeah.
Like they're like completely deformed.
Maybe it looks like a half a crater. Maybe here you have the old crater.
Yeah.
Like this.
Yeah, like there. Exactly.
Maybe here you have a structure like this.
I'm really pleased that participants have been looking at the base map in such detail. I thought, everyone's going to stand back and, just draw the crater rim because that's easy. But I'm really impressed that.
Oh, it's so much fun.
I'm glad, Pamela. Good. Okay, so I realize that the practical has overrun now by about 7 minutes. The thing that everyone must do, the participants, is to take a screenshot of their map, and please don't be embarrassed about what state it's in. I mean, I've already shown you mine. It was a disaster. I didn't close one of my polygons. Valentina will never want to be associated with me again because I forgot to close a contact somewhere.
You didn't see my map.
Well, you see, I know that you're a perfectionist, and I think perfectionists will be very slow about this sort of work. But so I think actually it's better to be reckless whenever you're trying to do these practicals quickly. So the only thing people need to do is I've posted a link in the chat, and the participants, if you could take a screenshot of your map and save it with a file name that has your name in it, then that way there will be some proof that you took part today, and Matteo will release you a certificate of participation. So make sure that you do that. I'm going to take a look at the link to see if people are filling it up. And thank you so much for taking part. And I think once you've uploaded your screenshot, you can leave, but feel free to carry on working on the project. And I'm sure we'll see you later on in the winter school.
Okay.
Maybe the instructors, if you want to stick around, I think Ben sent me a request. I think it was a request for a debrief, so we can discuss if there were any issues, and maybe we can improve the rest of the practicals or give some advice. but maybe the instructors who are not involved in other practicals, if they have no points to make, like Laura and Paolo, if you want to go, I think that should be okay. If at least Valentina sticks around, that would be fine.
I can stay, no problem for me.
Can I ask something, Gianluca?
Oh, of course, Gianluca, go ahead.
Okay. So because in my PhD project, I'm probably going to have to produce some digital elevation models of Mercury.
Okay.
And I've already made some attempts using the NASA's AMES stereo pipeline to produce some digital elevation models using the stereo photogrammetry.
Yep.
But preliminary results were not very as I was expecting.
Okay. Yeah.
So maybe now it's a bit late, and but I was just wondering if there would be maybe another occasion to just give some recommendations, some tips to produce some or to import some digital elevation models. I don't know.
You're asking me for advice on how to use NASA Ames stereo pipeline to make a DEM. I've never done it before.
No, not through AMES stereo pipeline, because I was thinking also, for example, if the Mercury laser altimeter data are available in a way similar to the MOLA of Mars, so that maybe if it was possible to, I've never tried, that's why I'm asking, if it's possible to download data already processed of the Mercury laser altimeter and import this data on the GIS.
Yes, it is. You have a choice. You can either download the individual laser tracks for the Mercury laser altimeter from the Messenger mission. They, because of Messenger's orbit, they don't exist for the Southern Hemisphere pretty much. And really, they are not great south of 50 degrees north. And really, you know, that's already not great. So for this area you were mapping, the laser altimetry is already not so good because we're at about 35 degrees north here, I think. And then there is also a gridded DEM made from the laser altimetry for the Northern Hemisphere. So that is also downloadable. Those things can be retrieved from, I can't remember who lectured you yesterday, but showed you the, maybe it was Ricardo, showed you the Orbital Data Explorer. There's one of those for Mercury, so you can get them from there. And then Valentina just briefly mentioned to me that there is a DLR, so that's the German Space Agency. They workers there have made a stereo photogrammetry DEM of the area that we were looking at today, a much larger area, but it encompasses the area we're looking at here. And it has a generally better spatial resolution than the laser altimetry at this latitude, about 222 meters per pixel. So there are digital elevation models for this area and other parts of Mercury, certainly.
From DLR, you said?
DLR, it's the German space agency.
Okay, great.
Deutsches Luft- und Raumfahrt.
Thank you for helping me with my German, Dave. If you're interested, Gianluca, you can email me and I can send you the links for these things. I don't have them. I can't find them quickly for you now, but you can contact me. I will send you. They're all freely available.
Good, great. Okay, so I will send you an email.
The link to the dataset repository of Messenger. So you can get them from there.
Okay.